Well, now let's move forward and let's solve a logarithmic inequality, or a couple of them, as the case may be. All right, so here we start off. We got log base 4 of x is greater than or equal to 3. And we don't have the log on both sides of the inequality. So I'm going to have to use the definition of logarithm and convert that log into exponential form. And as we get started here, the other thing too, I think I saw was in the last video, I was talking about how you can't take the log of a negative number. You also can't take the log of 0. So it's got to be a positive number. And that really won't have a whole lot of impact in this first example, but it will in the second. But let's move forward and let's write this in exponential form. So we know that the 4 is the base, the 3 is the exponent. So then x is now greater than or equal to 4 cubed. And we just compute 4 cubed where x is greater than or equal to 64. And so if x is greater than or 64, I don't have any problems about trying to take the log of a negative number or even a log of 0. And so we can express our answer in set builder notation as x such that x is greater than or equal to 64. And we solve that inequality. Now, in the next thing that we're going to look at, where we got log base 2 of x is less than 4, I've got to be aware of this situation to what could cause me to take the log of something less, well, either 0 or a negative number. But we are going to, since we do have just a log on one side, we're going to rewrite that in exponential form so that x is now less than 2 to the 4th power, 2 being the base, 4 being the exponent, x being the answer in this case. And 2 to the 4th power, of course, is 16. So x is less than 16. Now here's where I got to be careful in how I express my answer, because it's going to be x such that x is greater than 0, because it can't be 0, can't be less than 0. X cannot be equal 0 or a negative number. And it's less than 16. And so in reality, our solution set is between anything greater than 0 up to but not including 16. Well, there we go. We have solved a logarithmic inequality. Be careful with the less thans. Because they could trip you up if you're not really being careful.